Hi children, how are you? Hope all you are fine and safe. Today we are going to discuss about computational thinking. Computational thinking is the thought processes involved in formulating a problem and expressing its solutions in a way that a man or machine can effectively carry out. So, to write any program, first we have to think computationally about the problem and its solution, and then we have to write the program in a programming language. Computational thinking allows us to take a complex problem, understand what is it, and develop possible solutions. We can then present these solutions in a way that a computer, a human, or both can understand. The process of planning and reaching the goals involves computational thinking of some kind. Computational thinking involves taking a complex problem and breaking it down into a series of small or more manageable problems. Each of these smaller problems can then be looked at individually, considering how similar problems have been solved previously, and focusing only on the important details while ignoring irrelevant information. Next, simple steps or rules to solve each of the smaller problem can be designed. Let us discuss the components of computational thinking in detail. Computational thinking is a technique used to solve problems logically and consists of four key components or pillars described as decomposition, pattern recognition, abstraction, algorithms. Next is decomposition. First we can discuss about decomposition. Decomposition is the process of breaking down a complex problem or system into smaller, easily manageable parts. These smaller problems are solved one after the other until the bigger complex problem is solved. This stage involves breaking down the problem into small components so that they can be tackled easily. The more we can break down a problem, the easier it is to solve. For example, suppose this is the problem. X is equal to minus b plus or minus root b square minus 4ac divided by 2a. Here, first look, this equation might appear a little scary, but if we decompose it, we will stand a better chance to solve it. We can decompose like this: b square 4ac, then b square minus 4ac, then b square minus 4 root of b square minus 4ac, then minus b plus root b square minus 4ac, then 2a, then x is equal to minus b plus root of b square minus 4ac by 2a. Repeat for minus b minus root b square minus 4ac by 2a. By noting down the steps to solve a problem, we can often recognize patterns, and by giving a list of steps, we are one step closer to creating an algorithm. Next is pattern recognition. Pattern recognition is the next process in succession that helps in identifying patterns or trends within a problem. Once we have decomposed a complex problem into smaller problems, the next step is to look at similarities they share. We look for patterns when we play games to decide when to do certain things. Based on experience, we develop shortcuts for mapping problem characteristics to arrive at a solution. What are patterns? Imagine that we want to draw a series of cats. All cats share common characteristics. Among other things, they all have eyes, tails, and fur. They also like to eat fish and make meow sound. Because we know that all cats have eyes, tails, and fur, we can make a good attempt at drawing a cat simply by including these common characteristics. In computational thinking, these characteristics are known as patterns. Once we know how to describe one cat, we can describe other by simply following this pattern. The only things that are different are the specifics. One cat may have green eyes, a long tail, and black fur. Another cat may have yellow eyes, short tail, and striped fur. If we want to draw a number of cats, finding a pattern to describe cats in general. For example, they all have eyes, tails, and fur, makes this task quicker and easier. We know that all cats follow this pattern, so we don't have to stop each time we start to draw a new cat to work this out. From the patterns we know cats follow, we can quickly draw several cats. Next is abstraction. It refers to focusing on important information only, ignoring irrelevant details. To reach a solution, we need to ignore unnecessary characteristics in order to focus on relevant details. It helps us identify specific similarities and difference between similar problems to work towards a solution. So, what is this important information that we need to focus on? In abstraction, the focus is mainly on general characteristics that are common to each element instead of specific details. Common example of abstraction process are a world map is an abstraction of Earth in terms of longitude and latitude, helping us describe the location and geography of a place. A sign of an easel in a store, example Walmart, is an abstraction of the items available in that aisle. Next is algorithm. We have broken down the big problem into smaller, easily manageable problems. We have identified similarities between these problems. We have focused on relevant details and ignored anything irrelevant. Now it is time to develop step-by-step instruction to solve each of the smaller problems, or the rules to follow when solving the problem. These simple steps or rules are used to program a computer to help solve a complex problem in the best possible way. They are also called algorithm. An algorithm is a plan, a set of step-by-step instructions used to solve a problem. Writing an algorithm requires extensive planning for it to work correctly. Next is Python programming language. Python is an open source, object-oriented, high-level programming language developed by Guido van Rossum in 1991. Presently owned by Python Software Foundation. Python is based on the ABC language, a teaching language creating to replace the programming language BASIC, which was developed earlier. Python is a general-purpose programming language that can be used effectively to build any kind of program that does not require direct access to the computer hardware. Features of Python. Python is an interactive, interpreted language with simple syntax. It has become increasingly popular because of its salient features, which are listed here. Python is interpreted, interactive, directly executed with pre-compiled code. This means that it is processed at runtime by the interpreter and we need not compile the program before executing it. It is a loosely typed object-oriented programming language with few keywords and simple English-like structure and is easy to learn. It is a free open source and portable language having a large repository of libraries. It takes less time to develop as Python programs than equivalent Java programs. This is because of it builds in high-level data types and its dynamic typing. It is extendable and extensible and highly efficient as there is no wastage of time in declaring the types of variable or arguments. It supports GUI, means graphical user interface, and garbage collection. It is easily compatible with other languages like C, C++, Core Java, etc. Python is used for both scientific and non-scientific programs. Advantages of Python. Apart from the above salient features, Python offers the following advantages: platform independent, readability, object-oriented programming language, higher productivity, less learning time, GUI programming, ample availability of libraries, syntax highlighting. Platform independent means it is platform independent and can run across different platforms like Windows, Linux, Mac OS, and other operating systems. Readability. Python programs use clear, simple, concise, and English-like instructions that are easily to read and understand when by non-programmers or people with no substantial programming background. Object-oriented programming language. It is an interactive, interpreted or object-oriented programming language. Higher productivity. Since Python is a simple language with small codes and extensive libraries, it offers higher productivity to programmers than languages like C++ and Java. So you write less and get more done. Less learning time. Because of the simple and shorter code, lesser time is required to understand and learn Python program. GUI programming. Python supports graphical user interface applications that can be created and ported to many system calls, libraries, and Windows systems such as Windows MFC, Macintosh, and the X Windows system of Unix. Ample availability of libraries. It provides large standard libraries to solve a task. Syntax highlighting. It allows to distinguish between input, output, and error messages by different color codes. Next is limitation of Python. Apart from several advantages that Python offers which make it one of the most popular programming language, it has a few limitations as well. Speed. It is slower than C or C++. However, Python is high-level language, unlike or C++. It's not closer to hardware. Mobile development. Python is not a very good language for mobile development. It is seen as a weak language for mobile computing. This is the reason very few mobile applications are built in it. Memory consumption. Python is not a good choice for memory-intensive tasks. Due to the flexibility of the data types, Python's memory consumption is also high. Database access. It has limitations with database access as compared to popular technologies like Java database connectivity, Open database connectivity. Python's database access layer is found to be a bit underdeveloped and primitive. It cannot be applied in the enterprises that need smooth interaction of complex legacy data. Next, runtime errors. Python programmers have cited several issues with the designing of the language. Because the language is dynamically typed, it requires more testing and has errors that only show up at runtime. I think you understand what all things we studied. If you have any doubts, you can note it and ask when we are coming in live. Thank you all.